Test-driven development. Test-driven development is a software development practice where tests are written before the actual code. In simple terms, TDD is all about developing software by repeatedly writing tests, then writing code to pass those tests, and finally refactoring the code for improvement. It emphasizes writing clean, reliable code by following a strict cycle of creating failing tests, writing code to make those tests pass, and then refining the code base. The TDD cycle. The TDD process follows a simple, repetitive cycle known as Red-Green-Refactor. 1. Red. First, write a test for a small part of the functionality. The test will fail because there is no code implemented yet. This is called the red phase, where the test fails intentionally. 2. Green. Then, write just enough code to make the test pass. The goal is not to write perfect or complete code, but to simply make the test pass. This is the green phase when the test passes successfully. 3. Refactor. Finally, improve the code without changing its behavior. This is called refactoring, where you clean up the code, improve its design, and make it more maintainable while ensuring all tests still pass. This cycle is repeated for every feature or functionality, allowing developers to build systems incrementally with confidence. Key concepts of TDD. Unit testing. TDD heavily relies on unit tests, which are small, isolated tests that verify the behavior of individual units of code, usually functions or methods. Each test is focused on one piece of functionality, ensuring that small parts of the system work as expected. Test first. The core idea behind TDD is that tests are written before any production code. Writing tests first helps ensure that the code is written with testability in mind and focuses on meeting the requirements. Continuous feedback. With TDD, developers get immediate feedback after writing each small piece of code. If a test fails, they know something is wrong, allowing them to fix the issue early in the development process. Refactoring. TDD encourages constant refactoring. Once a test passes, developers are encouraged to clean up the code without changing its behavior. This helps keep the code simple, maintainable, and free from duplication. Code quality. Writing tests first forces developers to think about the design and structure of the code, leading to cleaner, more maintainable code. Fewer bugs. Since code is tested at every step, TDD helps catch bugs early, resulting in more reliable and stable software. Confidence. Developers have higher confidence when making changes because they know if something breaks, the tests will catch it immediately. Documentation. Tests act as a form of living documentation. They describe how the code is supposed to work, which can be helpful for future developers or when revisiting old code. Real-life use case. Building a calculator app. Imagine you're building a simple calculator app that can add, subtract, multiply, and divide numbers. 1. First, you start by writing a test for the addition function. You write a test that says, if you call add to 3, it should return 5. Initially, the test will fail since the function add hasn't been written yet, red phase. Next, you write the actual add function, just enough code to make the test pass. Add AB gives A plus B, and now the test passes, green phase. 3. Finally, you refactor the code, ensuring that the add function is well-structured, readable, and doesn't contain unnecessary complexity, refactor phase. This process is repeated for subtraction, multiplication, and division functions. Over time, you build a fully functioning calculator app where every function is well-tested. Challenges of TDD. Time-consuming. Writing tests before the code can sometimes feel slow, especially for simple functionality. However, this investment saves time in the long run by reducing bugs and improving the code base's quality. Overemphasis on testing. In some cases, developers may focus too much on making tests pass instead of thinking deeply about the overall design of the application. It's important to balance both testing and design. Maintenance of tests. As the codebase grows, maintaining a large set of tests can become challenging. However, good test management and refactoring practices can help address this issue. Practical example, TDD in e-commerce. In a real-world e-commerce platform, TDD can be used to develop the shopping cart feature. For example, you could start by writing a test to ensure that when an item is added to the cart's total reflects the correct price. Initially, the test will fail because the cart functionality hasn't been implemented yet. Afterward, you would write the code to add items to the cart and calculate the total, ensuring the test passes. By following this process for different features, like removing items, applying discounts, or calculating taxes, developers can ensure each part of the cart works as expected before moving on to the next functionality. Conclusion. Test-driven development is a powerful methodology that improves the quality, reliability, and maintainability of software. By following the Red-Green-Refactor cycle, writing tests first, and focusing on continuous feedback and refactoring, developers can create robust applications that are easier to maintain and extend. Although it may seem like a slower process initially, the benefits of fewer bugs, higher confidence, and cleaner code make TDD a valuable approach in both small projects and large-scale software systems.